political concerns are building up because you can see where they are, and they're very heavily in China, Australia, South Africa, and to some extent in the Americas. Now that seems a bit of a worry. For example, virtually all the rare earths we know about now are in China. And it's even more interesting in many ways because I've said at the bottom, and who owns the mineral rights to those that are left? And the answer is, to a large extent, the Chinese. The Chinese have bought out the mineral rights to many of those minerals in Australia, Africa, and Americas, and so on. And you may have read recently there has been a big fuss in the newspapers because the Chinese have been trying to buy the Canadian company Potash, which is the world's largest supplier of potassium. And people probably read that and go, so what? So what? Well, potassium is fundamental to fertilizers. If you take potassium away, say, from Brazil, they'll stop growing stuff. We'll stop growing stuff. You know, there's some really fundamental issues in there that people need to wake up to. And it's all down to the fact, as I say, that we disperse our original materials. At 1 minute was a resource and the next minute it's become a waste. And we're very, very bad in the fundamentals of waste management. You know, just to get the whole process started, we have to be able to manage the waste. We call it recycling, but again, as you heard yesterday, and I'm sure you realize that even when we think we're recycling stuff, what we actually do with it is not necessarily that good. Very little of what we actually recycle ends up being recycled, I would say, effectively and cleanly. But at least it's a start. But we don't even do that very well. The poor Bulgarians don't recycle anything. They landfill the whole lot. And as you know, of course, some of the Benelux countries are rather better than us. The Japanese are better than us. But on the whole, you know, the majority of countries are not very good at waste management. So, for example, GSK, a company I've worked with for many years. GSK, as you probably know, apart from the pharmaceuticals, they also make various other products like Lucozade and Ribena. So a couple of years ago, they decided they wanted to make the Ribena bottle from something greener. And they looked at all the alternatives about what type of plastic could be used to replace the PET in a Ribena bottle. And it's actually very difficult because that bottle has got all sorts of important characteristics with regards to keeping the drink fresh, not being coloured by the colorants in there from the fruit and so on. And they ended up deciding the best solution was to recycle PET. So they said, okay, we'll just go out and get some recycled PET from waste management streams. They could not, in the UK, get enough recycled PET to make Ribena bottles. They had to basically set up a huge new infrastructure to get people to sponsoring local Boy Scout groups and all sorts of things to basically collect together PET to give them enough PET for recycled purposes to reuse again in bottles. And now they've got the world's first 100% recycled PET bottle, which I think is great. I think it's a very nice example. But it also proves the point about how terrible we are at waste management. And then beyond that, of course, it's not just waste management. You've got to do the processing to get the recovered plastic and turn it into something you can use again, which is not trivial, especially if you want to use it effectively for something more valuable than some of the applications you see. This is not a trivial thing. I'm not saying it's not the right thing. It is the right thing, but it is challenging. It needs technical solutions like all of this. We have to do more than talk. We have to do stuff. What GSK did is not perfect, but at least it was a step in the right direction. We need to get green chemistry across all the supply chain. As I've hopefully shown you, we need to think about all the different stages in the supply chain. And this is basically a kind of illustration of the way we work. So basically our approach is to say we need to engage all the stages in the supply chain. So we spend a lot of time working with consumers, as you can tell from our exhibition when you visit it later. We spend a lot of time working with retailers, which is a project we call Green Chemistry and the Consumer. And that was originally sponsored by Marks and Spencer 7-8 years ago. So thanks to them, they were really good at a time when other people were like, what are you talking about, you know? You go to people like retailers and you say, you talk green chemistry. We don't do chemistry. We don't do chemicals. And that's everything you sell contains chemicals. I had a drink with one of the guys, the guy in charge of CSR, I think it was, for John Lewis. And I was saying to him, you know, everything you sell contains chemicals. And he said, well, we sell over 100,000 different articles. You know, where should I start? And I said, have another drink. You know, it's like, you know, this is a bit challenging. And you've got to go all the way back and think production, like people like Unilever, P&G, these huge companies. P&G, amazing. You know, P&G have said by 2020, they want half of the substances used in all the articles they sell to be based on renewable or recycled materials. That's an enormous challenge. And in-house, the CEOs also told these people to aim for zero waste across the supply chain. And I said, does that mean your raw material suppliers? And they said, yes. Their raw material suppliers are everywhere on the planet. Does that mean the consumer? And this again produces this interesting, I think it was hinted at yesterday, this interesting situation. How do you influence the consumer in terms of what they do to minimize or even make zero waste? Hugely challenging. I don't mind setting targets which theoretically are probably impossible, but at least they set challenging targets, you know? So if somebody says zero waste, it's pretty clear what they're aiming for. And also, unless they're completely stupid, they know it can't be really zero waste, but at least it gives you an ambitious target to move towards, which I like. So these are all important things. And I've said they're reducing carbon footprint. I haven't got time to talk about the so-called metrics of measuring the environmental footprint. And that is a massive issue I'm very aware of. And sitting next to someone from the University of Manchester, where they've been doing some interesting work there, and there's all sorts of activities going on. We have to deal with this because I spend a lot of my time talking to people and they will say, how do I know that that intermediate somebody's trying to sell me is genuinely greener? And it's like, yeah, okay. That is not easy. If you do LCA is an enormously complicated, time-consuming activity. You can't afford that. But at the same time, you can't afford to be just superficial and say, well, it's greener, isn't it? Because it hasn't got chlorine in, or because I can recycle it, or because it comes from a renewable resource. No. That probably helps, but it doesn't mean to say it's necessarily greener. You've got to look across the life cycle, at least qualitatively. And the challenge there is enormous. I do appreciate that. And a lot of companies are looking at this in-house, out-of-house and stuff. Something to be aware of. So, waste is there. You know, we will always generate waste. So, you know, to me, although we are very interested and are working on designing products to be reused again at the end of life, to me it's all about, you know, the waste, the volumes of waste we have in society are huge already. I mean, I do a lot of work with Brazil these days because to me Brazil represents so much of the future. They've got a wonderful can-do attitude. They reckon they can grow anything better than anybody else. Everything's growing in terms of the, society, in terms of the industry and so on. They told me the other day they want to be leaders in in green chemistry, which is great. I was there recently for the opening of the Brazilian Green Chemistry School. There's a lot of very positive stuff going on there. Absolutely fantastic. In one place in Brazil, in Fortaleza, in the northeast of Brazil, they have every year 2 million tons of waste cashew. Cashews, you know? That's just one part of one country. 2 million tons a year of waste cashew. You go to India and Vietnam, which is coming up quickly, in terms of cashew production, you have similar situations. Now, you start looking at other types of waste. For example, chocolate. You know, chocolate is responsible for something of the order of 25 million tons of waste a year. Ridiculous. You know, the efficiency in getting chocolate out for us to eat is incredibly low. It's a very poor resource efficiency industry. But we don't think about that, do we? What happens to all that waste? So, you know, we already have an enormous amount of waste we're producing, which actually we should be utilizing for making things. And that helps the local economies, it solves the waste, but it's a classic, you know, win-win situation. We need to do more of it. We need to make better use of that, be it food waste, geez, you know, you all know about food waste. I mean, people talk about food versus fuel versus feed versus chemicals versus materials. For heaven's sake, look at it. You grow something on a field, you know, like some wheat. You thought about the efficiency of how much of that carbon that you grow do we eat? I reckon it's probably about 10%. By the time you've allowed for half the carbon stays on the field in the form of straws and other bits, you lose various carbon in terms of production, then there's processing, then there's the actual retailer who throws a lot away, then us. Of course, we throw away about a third of the food we buy, and some types of food, certainly. So, you know, the efficiency is so low. I'm a chemist. I shouldn't be fussy about where the carbon comes from. I don't want virgin food. I'll quite happily accept the stuff left in the farm or the production facility or the retailer or the household if we can just manage the waste. It's all carbon. It's all sources of carbon and other elements, as I was showing you earlier. So let's be cleverer about using what's already out there, what's already happening. Newspaper waste. You know, we work with the Carbon Trust, and we did a survey of where are the highest concentrations of renewable carbon in the UK. And one of the highest is newspaper in the docks at Immingham, because we collect all of those waste newspaper, ship off to various places, who knows where. It's already managed that stuff, actually, so we're thinking, great, we should be applying technologies where the carbon's already there. Otherwise, they don't recycle much of it. Most of it ends up as a waste. We can use that. So all sorts of exciting possibilities. And waste electronics, of course, which is where a lot of those elements I talked about before. Waste electronics is a massive problem. You go to a landfill site, which I take my students to occasionally. They come back with souvenirs. I love it. They're great, you know, nature's natural scavengers. And you go there, and they're dealing with a lot of the waste, but they can't deal with the the waste electronic and electrical equipment. They have mountains of those stuff on every landfill site. And they're assembling it by hand, or even worse, they're shipping it abroad, where they're assembling it by hand not very well, as in, you know, creating all sorts of environmental and health problems as well. So let's find ways to make use of the waste streams as we're designing newer products which don't generate such waste streams. Here's one of our ideas that we published in Le Monde, which is all about saying, okay, in the so-called biorefinery of the future, which is one of my great sort of loves at the moment, you could actually recover lots of metals by having situations where you use plants and other natural agents that are capable of capturing elements. Now, plants are amazing scavengers, you know. The thing that really made me realize this, I'm not a plant biologist, but one of my guys is Ukrainian, and his father was actually killed just after Chernobyl as a scientist going into Chernobyl, so we have some real sort of connections there. And I know some of the guys who work in that region, and when they went into Chernobyl when they first went in, they found plants were growing amazingly quickly, even though they were absorbing huge amounts of radionucleotides that normally you'd think were deadly. Plants adapt incredibly well. Plants will absorb huge quantities of metals into their root systems. The challenge then is to get out the metals out again. You could do that, for example, by taking the so-called biomass, the whole plant, use it for energy, fermentation, AD, combustion, pyrolysis, whatever, and then take the ashes, and then that's where the metals are, and extract the metals from the ashes. This is all known technology. You know, we can do it. Okay, we need to do it better. We need to be more efficient. But essentially, the essential sort of parts of the toolkit are there. It just needs us to exploit them better and to realize they need to be exploited. And even after you've done that, by the way, don't forget the sort of toxicity issues, the hazard issues. This is looking at the elements from a different perspective. This is saying which of the elements should we avoid using. So there is legislation in the European Union, again, called Restriction on Hazardous Substances, which actually restricts the use of certain elements in the making of electronics and so on, because they're considered to be quite dangerous. Cadmium, mercury, lead, we all recognize as being toxic elements we shouldn't use. But I just wanted to divert from my talk a little bit to talk about one in yellow. So yellow in that code means okay, according to the European Union, which is based entirely on the toxicity or environmental impact of the final product. So the one I'm looking at is called TA, number 73. That's called tantalum. And tantalum, a rather obscure element, even most chemists wouldn't think about. But tantalum is used in every mobile phone, so chances are each of you actually have tantalum in your pockets. It's an essential element for making mobile phones and other things. The interesting question is, where does the tantalum come from? It's not toxic, absolutely. There's no significant environmental impact when tantalum goes into the soil and so on. That's not the problem. The problem for tantalum is the resource. We mine tantalum in Central Africa, in places where, you know, the local gorilla population's just gone. You know, it's devastating conditions to the environment to get tantalum for us at a lower price. Actually, it's available in Australia, but they can do it so cheaply in Central Africa because basically there's low wages and there's very poor, if any, environmental control at all. And it gets worse. This is the process. So again, a fix for the chemists among you. And what this shows you is how they go from tantalum ore to electronic products. Now, even without being a chemist, I'll give you some hints. In the red there's some substances that even as a chemist I would not touch. There's something there called HF, hydrofluoric acid. As I said, in my past existence, I was a fluorine chemist. I know. HF is extremely unpleasant. It will burn straight through your finger, bone, tissue, the lot. It is deadly stuff. You then mix that with concentrated sulfuric acid, which I'm sure you all realize isn't good. And just for fun later on, you use some molten sodium. Molten sodium? Bloody hell, you know. This is the devil's chemistry kit, this is, you know. And this is what they do to get us tantalum for our mobile phones, having already wiped out the local gorilla population and the environment, you know. This is unbelievable. Do we think about that? No, we don't. Is there any legislation to control that? Not at all. But this is what you need to face if you're going to go back in your supply chains and really challenge all these things. We have to recognize all these. Awareness is the first thing we need to know. We need to be aware of these issues. Okay, as I said, carbon's